Okay. So tell me if you have heard about multi-threading earlier, or what do you understand by multi-threading? Yes, Rishikesh and Bhaskar, let me know, like, what is your understanding about multi-threading?
So I do I don't know that much about multi-threading.
Okay, that's fine. I think Rishikesh, you must have read maybe in any other programming language.
Yeah, sir. But I don't remember. I hear that word, but
Okay. Mhm. Fine, fine, that's fine. So let me explain. Now, if we look at our mobiles, or if we look at the laptops or desktops these days, so
okay.
here I have the this is Microsoft Paint, which is opened up. I have this Google Chrome, which is opened up. I again have the Jupyter Notebook process running. So at one time, I have so many different processes, or rather, I can say programs, or in general, we call them as softwares. So at a single point of time, I have more than one particular software which is running, and like they are active, they are all active. It's not like this is active and the other is passive. No, it's very much active. The process is live and running. And similar way, the page is also active and it's live and running. So the ability of a computer to start multiple applications was a need, like it was needed basically. Okay, so multiple applications running simultaneously. So this is the requirement or the need, and how to achieve it. So it can be achieved in two ways. One is multi-processing, and another way is multi-threading. So these are the two mechanisms which help us to run multiple applications simultaneously. Okay, right. So there is a minor difference between these two things. Okay, one is multi-processing, another is multi-threading. So in order to understand that, we should understand what is a process, and we should understand what is a thread. So these two things needs to be understood: process and threads. Right. The process, again in very layman's term, I can call it as a program, or to be a bit specific, I can say that program in running state. So a program which is running, that is known as a process. Then what is a thread? Thread is basically an, or rather I should say, smallest executable entity in a process. So thread is smallest execution entity within a process. Okay. So now you can just imagine. So let's say this paint is running. This paint is a software which is running, and this is nothing but a program. And I double clicked on the icon, or I just typed the name of paint into pressing the Windows button, and I could able to open up this program, which means that I could able to run the process. So as soon as I run this particular process of Paint, so at the background, there might be maybe 10, 20, or more than that, small processes are running. Okay, this Paint is a software. To run this software, there might be 2, 3, 4, 10 processes running. And inside that particular process, there are multiple threads. Okay,
Hmm.
so if you draw it, it is something like this. This is a software. Inside the software, we have process. So let's say we have two processes. This is one, and we have another process. The two process runs the whole software. And inside this process, we will have threads. Okay, so this is a thread. This is another thread. This way, multiple threads are there inside a particular process. Okay, fine. So these are multiple threads. So the smallest executable unit. So that's a piece of code itself. So this particular is a piece of code which can be independently executed. And similarly, it will be running carols as well. This is a software, and this is a process. And this is a thread. So it basically runs this way. Fine. As I said, if I want multiprocessing to be executed, that multiple applications running simultaneously. So one is multiprocessing, another is multithreading. So multiprocessing is higher level of achieving multiple applications running simultaneously, and multithreading is going to the lower level. Okay, at the smallest execution level entity we are going, and then we are doing it. Okay, right. Okay. So if you look at this program, so you can see some import statement, some function def, and then you can see try except block. So uh, before understanding the program, one understanding, whenever you are writing a program, then this try except, which is a part of exception handling, which we had covered in one of the sessions. So at every time you will see that exception handling has been used. and I had explained the reason also, because exception handling is a concept to basically minimize the effect of the errors or exceptions occurred. So whenever there is an exception or there is an error, so the program halts abruptly. It does not wait for any other part of the program to get executed. It just simply breaks up the program then and there itself, and it displays the particular error. So wherever you feel that exception may occur, you put that particular code in the try block. And after that, if the exception will really occur, you write the except block and just write there what kind of exception may have occurred. Okay. So in this case, the process of thread has been written into try block, and if it does not start, it will go to accept and it will print error unable to start the thread. Okay, right. Now coming to the first line, import thread, or you can see that it's rather underscore thread. So this underscore thread is a package, and it is used for implementing multi-threading for any particular program. Okay, and whenever you have more than one functionalities or more than one functions to be executed simultaneously, that time you make use of thread. So this is a package. That's fine. Fine. Yeah. And then second is import time. So that's another package to basically handle time. Okay, system time. So you can import it, or you can have any other example. So this example we have thread package, and we are making use of time. Therefore, we have imported the time module. And here we have a function now, def print time, and inside that we have thread name and we have delay. Inside the function, we have two parameters. One is thread name and another is delay. Two parameters we have. Okay. Then here you can see count is equal to 0, while count is less than 5. Time dot sleep, and here we have delay. Okay. So now time dot sleep, and in bracket it has been mentioned delay. Okay. So which means that the user will pass some value in the delay, and that would be the time, and sleep method means for that particular time, let's say it's 1 second, for one particular second the thread will sleep. Sleep means it will not process or execute. Okay, and then we are doing count plus is equal to 1. This is just to increase the counter of the count, which is 0, and it will increase every time these conditions are getting fulfilled. And finally, we will have count as equal to 5. Right, and that time the while loop will be over. The control will come out of the while loop. Okay. So now this is a function. Okay. Why it has been used, you will not understand now. Like why this function has been created. Okay. So this is created just to demonstrate the functionality of threading, multi-threading. Now if you see here, underscore thread dot start new thread. So this is the package. Underscore thread is the package name, and then we have written dot start new thread. So this is a function, and inside the function we have print time. Okay, so what is this print time? Here you see right? Print time function we have called, and then we have passed thread name and delay. This is thread 1 is the thread name and delay is of 2 seconds. Thread 2 is the thread name and 4 is the second. And now when I will execute this, either it will get executed or if it will not, then it will come to except part and print the error. Okay. This is of no use. Let us now execute this. Control enter. So try to observe the output. This is the output. Right. Now let us start understanding the output. So here in try, if you see, try, we have called underscore thread dot start new thread. Okay. And thread 1 we have passed the name and 2 is the delay. And another is underscore thread dot start new thread. Again, thread 2 is the name and 4 is the delay. So if you see that the thread 1 is started first and then thread 2 is started. So as soon as the thread 1 is started, it has executed, it has printed the name of the thread and the whole of the details. Immediately after that, it has started the thread 2. So if you see 57, thread 1 has started, right? Observe this. At 59, thread 2 is started. But if you see, the delay is 2 seconds here for thread 1. So 57, 58, 59. Okay. So after 57, it's like plus 2 seconds will be 59. So thread 1 is executed again at 59. Just see here. Thread 1. Okay. And for thread 2, we have 4 seconds. So 4 means 59, then 60, 61. So after that, 1 will be there. So 60, 1, 2, 3. Okay. So after 59, 60, 1, 2, 3. So at 3, thread 2 is again started. Okay. But before that, again after 2 seconds, thread 1 will get started. Okay. So I hope you are getting, like, thread 1 will always get executed after 2 seconds and thread 2 will always get executed after 4 seconds, and whenever 2 and 4 okay, after 2 and 4 seconds, even if the time is matching, they will execute parallelly, and that's what we are able to see here, right? Yes. So this is the concept of multi-threading. Again, repeating that at particular one time, more than one processes should run. In our case, what is the process? The process is to print time. Okay, that is the process. Okay, so print time is the process. We have written a function for print time. Okay, and in both are the same process, and in each of the process we have passed one thread as thread 1, another thread as thread 2. Why 2 threads? Because we wanted to check that at a particular time whether both the threads get executed or not. And we found that whenever there is the execution time matching, so at that particular time they will parallelly execute. Okay, tell me if you understand this. Okay, the process print time is getting executed parallelly two times because we have called it two times with the help of two threads. Okay, because these are threads, therefore they are getting executed at same time. This is one example. At 59 seconds, both the processes got executed. Similarly, at 03 seconds, both the processes get executed parallelly. Okay, this is what is called as multi-threading. Okay, is it clear?
Yes, sir.
Sir, in the initial, when we are writing the headers, sir, why do we write import time and import? There was another line, right? So,
Yes,
sir, could you explain that, please?
yes. So import thread
Import
and import time.
underscore thread and import time.
Yes. So import thread. So here if you see inside try, I have made use of underscore thread dot start new thread. So what I have done, I have made use of a function that is start underscore new underscore thread. This is the inbuilt function, but it is inbuilt under underscore thread package. So this underscore thread is a package which I need to import first in order to make use of this particular function. And therefore I have imported underscore thread. Second, time, because I wanted a process to go for sleep. Go for sleep means that particular process will be in idle state, or you can say that particular process will be inactive for those number of seconds which I pass. So here if you see time dot sleep and in bracket it is given delay. So this delay comes from here 2 and 4. So time dot sleep, this sleep is a function of time. So as soon as print time function gets executed and it will go inside the while loop, this time dot sleep will make the print time function sleeping or inactive for some number of seconds, which is passed in the delay. So if it is 2, for 2 seconds, there will be nothing happening here inside the print time. Okay. So now if you understand, because I wanted to use sleep function, I wanted to use time dot c time, time dot time. So I wanted to use these functions, and these functions are present inside a package named as time. So I need to import that particular package as
Time.
time. Yeah, so that is the purpose. So understand that few things are by default. For example, defining a function is default thing. You need not to import anything for defining a function. But many things are not default. They need to be explicitly imported and then we can use them. And this is good also. Because if at the beginning itself we have everything imported, then the whole of the process of writing any program in Python will be too slow because everything is imported. But here we have a freedom and choice. Whatever we require, we can import that particular thing and and only that much load will be given to the interpreter. Okay, so I hope it's clear now.
Yes, sir.
Okay, so this is another example with a different package. Now, if you see, we have a package here underscore thread. Okay, we have another package. Okay, it's like let's say I want to have ice cream. So I normally have let's say a chocolate flavor of it. But now someday I thought, let's try something else, and I went for vanilla flavor. Okay, so both are the ice creams. But one day I had a chocolate flavor, another day I had a vanilla flavor. So similar way, we have multiple packages for one particular functionality. Now we are discussing about multi-threading. So we have multiple packages for implementing multi-threading. So one package we just saw in this example is thread, or rather I should say underscore thread. Similar way, we have a package called as threading. Okay. So now I'm doing here import threading instead of import underscore threads. So you should not get confused that what is threading or what is underscore thread. They are same thing. Okay. I'll say they are meant to achieve same thing. Okay. They are not meant to achieve multiple or different things. They are both to achieve multi-threading. Okay. So now if the package is different, so the internal functions will also be different. Okay, the internal functions will also be different. So now here what we will see is that what are the internal functions inside this threading. Again, I have a definition print cube. I have a def that is function print square. Okay, so two functions are there, print cube and print square. Okay, two functions are there. Now you can understand why two functions, because we will just see that whether they are getting executed simultaneously or not. Okay, and then we have here print cube dot format num into num into num. So if you pass one number here, okay, let me just remove this. We don't require this. Okay, only this much is there. The function to print cube of a given number. If you pass 1 here, that will do 1 into 1 into 1, 2, 2 into 2 into 2. So it identifies cube, and this function identifies the square. So num into num this way. Fine. And then we have if underscore underscore name is equal to underscore underscore main, then okay, here you see T1 is equal to threading dot thread. Okay, now understand the difference. In underscore thread, we had a method underscore thread start new thread. So that was a method, and here threading has got another way of creating a thread and starting that particular thread. So the method is what we are doing. T1 is equal to threading dot thread target is equal to print square args 10. Okay, again T2 is equal to threading dot thread target is equal to print cube args 10. Okay, so you might be able to understand what exactly is this. Okay, so here T1 is a variable name is equal to the assignment operator, then threading dot thread. So threading is the package name, and dot thread is the function which comes under package threading, and then target. So target is what to execute. So print square function needs to be executed in T1. Similarly in T2, if you see what needs to be executed, print Q needs to be executed in T2. And now args means arguments. So arguments is 10 comma. Okay, so now just remember, whenever you are passing arguments this way, you'll have to pass the argument, and at the end you just need to put the comma. Okay, I'll explain you later why is that. So this args 10 basically will come to num. So it will come here, and then it will print the first thread will print the square, second thread will print the cube. So this is what we will get. Two threads are started here in a different way because we are using a different package. Not started, they are just created. So here we have another function, that is start function, to start a particular thread. So what we have done is T1 dot start and T2 dot start. So dot start method will start the thread. So because we have started, the T1 first, T1 will get executed first, and T2 will get executed second. Okay, and because this is example of multi-threading, so they will parallelly keep on getting executed. Okay, okay. So let me just comment all this. Okay, and now Control Enter. Not yet executed. Let me do kernel restart real output. Okay, okay, yes. So both the thread got executed. One calculated the square, another calculated the uh, cube. Let me put slash m here. Control Enter. Okay, slash n will take it. Done. Okay, and let me do this uncomment now. So sorry, basically, here we are not getting anything. Okay, so join functionality if you want to see, we can do this. Let's have this function and let's have one more notebook created. So, code So let's just try executing this. Okay. So try to observe this. So here what happened? The first one started, second started, then the second one should run after 4 seconds. So it ran after 1, 2, 3. Okay, 44. Then first thread again started, and then okay, second. Fine. And let's make the argument same. Let's make the argument same. Okay, now let's check. And if I uncomment it, now let's check the output. Okay, so the only done part, if you see, the done part comes at the end. Okay, otherwise they are executing, they are getting executed. Okay, so it started at 27:30. It also started at 27:30. Okay, so parallelly they are running. But if I made it commented, if I comment this, then at that time, if I run it, so thread so done has come printed first, and then thread 2 got printed. Okay, okay. So if we have done t1 dot join, so done gets printed first, and then the last part of t2 is getting. Okay, now it is 2. So ideally now done should get printed, and then thread 1 should get printed. Okay, yes, fine. So 3 scenarios. First one, we are not making use of join. Join is a function basically. And second one, we are making use of a join either with T1 or with T2. So now what this join function does, if we want that the T2 thread should get executed completely, and after that the other thread or threads should get executed, then I should write at that particular place T2 dot join. Okay, so if you want a particular thread to get executed completely, so at that particular time you can write that particular thread name dot join. So this join method will help you to get that particular thread executed completely, and then it will proceed for the next any other threads. Okay, so this is what you can see here, because we have written t2 dot join. So here you can see it is thread 2 getting executed, and then after that we have thread 1 getting executed after that. Okay, after finishing the thread 2. So here also if you see in the first, so because thread 1 was started first, therefore its entry is first, then thread 2 entry is there, but after that if you see, thread 2 gets executed first, and then thread 1 gets executed, then thread 2 gets executed again first, then thread 1 gets executed, and similarly. Okay, so otherwise, because the thread 1 has started earlier, so every time the second iteration of the thread 1 should always be before the thread 2. Okay, but because we have used t2 dot join, therefore from leaving this one, from here if you see, thread 2 has always started first, and then thread 1 has got completed. Okay, are you getting the use of join? Yes, Rishikesh, Athar,
Yes,
Bhaskar, are you getting the use of join?
yes, sir.
Okay,
Yes, sir.
okay, fine. Okay, so yeah, so till now we have seen two packages. Firstly, we understood what is a process, what is a thread, and thread is basically the smallest executable unit inside a process. So you can say that one or more threads make a process, one or more process makes a program, and that program is called as a software. We have
Hmm.
seen one package as underscore thread, which has got a function called as start new thread, with which we are able to start or create a new thread and start that particular thread. Then we have seen another package called as threading,
Great.
and with the help of this package threading, we can create threads and start them. But there's a different way. The way is threading dot thread. This is how we need to create a thread, and then we can start a thread this way. T1 dot start. This is how we can start. It has also got a function called as join, and the join function will help us to execute a particular thread completely, and then it will go for the other threads. Otherwise, all the threads will parallelly keep on doing their tasks, their processes. Fine. Now we have a lot of functions under this threading module as well. So like active count, current thread, enumerate, then run, start, join. So there are multiple functions. You'll see them as well. And then there is a concept of synchronizing threads. We'll see this as well, but not today. In the tomorrow session, we'll see that. Okay. So just to tell you that underscore thread and multi-thread, threading. So out of these two, we will prefer to make use of threading because threading package gives us more functionality as compared to underscore thread. Okay, so we will be preferring a threading package instead of underscore thread. Okay,